Hello and welcome to my video journey of daily challenges. Let's start question number 15. Okay. Question number 491, non-decreasing subsequences. Given an integer array nums, return all the different possible non-decreasing subsequences of a given array with at least 2 elements. You may return the answer in any order. All right. So let's look at some examples. Example number 1, 4, 6, 7, 7, and the non-decreasing subsequences of length at least 2 are 4, 6, 4, 6, 7, 4, 6, 7, 7, 4, 7. Okay, so 4, 7. So they're actually skipping some numbers sometimes. 4, 7, 7, and 7, 7 is included because it's not decreasing. 7, 6, 6, 7, sorry, 6, 7, 7, and 7, 7. All right. So it seems like it's a complete sort of, would it be combination or permutation? It would be all a subset of all combinations, starting with 4 choose 2, 4 choose 3, and 4 choose 4, such that the sub-arrays are increasing. And in the constraints here, we have a pretty tight constraint saying that the length of nums is tiny. It's 15. So probably means that there is no fancy algorithm to solve this, and we'll just have to brute force the solution, meaning that the complexity comes in the brute force. Right away, what comes to my mind is the binary representation of numbers in computers, binary format. They look something like this: 1, 2, 3, 4, 5, and so on. You can see that if we were to bit mask, let's say the nums is of length 4, if we were to bit mask nums with every single number until 2 to the power of length of nums, we would be able to already find all the different combinations of this. The challenge there would be to pick out a subset of those that is valid. So right off the bat, we would exclude the ones that are of only 1. And yeah. Okay. So if this is the case, then one solution could be to do a bit mask. The other solution is something called backtracing, where you it's a recursive way of essentially it would be actually to do something like this. We would have a 1 0 0 0 0, then 1 1 0 0 1 0 1 0. So this is like big Indian representation of binary in computers, but 1 0 0 1. You can see that on the first level of recursion, we're doing all different combinations of the subarrays with one included, with the first element included in it. So let's start this implementation, and we'll actually have these commented out, but just for reference, they will be here. Let's define our backtrace function that's going to take the current element and the sequence of elements that we have already the sequence of the sequence of the array that we're currently on. And let me see if I can, I can say something like this: for I in range, current and length of nums, we are going to say that the current is 0, but the I is going to iterate over these 3 elements that are left. And the first thing that we're going to do is say that we need to add ourselves being this first element, into the sequence. So sequence append nums I. Now that we've added this element to the sequence, we're going to say backtrace the rest of the sequence. So the rest would mean that it's I, which we started +1, and the sequence that we've just to which we just appended the 0th element. And so on the first level of recursion, we have just knocked out the first element, all the different combinations of the first element from our answer. And actually, answer is going to be a set, because there could be duplicates. For example, 6, 7, and 6, 7. Answer is going to be a set, return answer. So now that we have, additionally, we would have to, additionally, we would have to pop this element from further levels of recursion, because so for example, if we were to be already one level deep in the recursion, we would be looking at all non-decreasing subarrays of 6, 7, 7. But what that means is that when we jump back out of this into the first level of recursion, we would have to exclude 6 from here. So let's do that. And this should, let's see what this actually prints. I'm generally interested. Expected ants. Oh, well, right, we're never populating answer. The way to populate ants with this given definition is if length of sequence is greater than 1. Ants append, it's add, and add sequence. Submit this. Run it. And the output is none. Why is it none? Because I'm never calling backtrace. This has to be a unhashable type, so lists are unhashable, but tuples are not. Let's see if this works. And case 1, we have, case 1, perfect. We have found all the different combinations, actually. If we were to turn this ants into a list, then we would never have to, we would probably be experiencing some duplicates. Output 4, 7, 4, 6, there should be at least a couple 6, 7s. There we go, 6, 7, and 6, 7. So this approach right here, you can see, is a way to and let's remove this also. This is approach to iterate through all the different combinations. This, in a sense, is this exactly right here, what we were doing. A way to generate all different combinations of zeros and ones for the length of num. And this should actually give us, let's see, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, sorry, 16 elements including 0 in our print response. But that's not what we're interested here. This is just me giving some general background. Add. And sorry, if len of sequence is greater than 1, then add it. Now, why were we going wrong on case 2? We're going wrong on case 2 because this is the other portion of the problem. So what you see happening here is each problem that I've experienced, they've sort of split up. Like for example, this on its own could be a problem, but the other constraint here is that the subarrays have to be always in increasing order. And what that really means is that as soon as we encounter a decreasing subarray, we exclude it from the call. We don't want it to be called. And the way that we could do that is if the current element in index I is smaller than the previous element or the last element in the sequence, then skip this whole backtrace completely. So last is going to be sequence of -1 if sequence, but in the case that it's 0, it's going to be, let's do -101 because that was the requirement here. And here we can say that if last is smaller than nums I, do this. Oops. If last is smaller or equal to nums, then do that. Sweet. Awesome. Okay. And we're beating a lot of the people here. I hope this made sense. Let's summarize. There's almost, would I say 2 or 3? Let's count. The first problem in this question is, how do we generate all the possible, I would say, binary numbers from 0 to 2 to the power of length n, or length of nums? How do we generate that those numbers in binary form? It could throw some people off, but this method of backtracing solves it by visually, it would be to compute all the different subarrays, including the 0th index, or the number at the 0th index, but then apply the same mentality to all subarrays excluding the 0th index, and so on until you've reached all of them. So on this first level, you see that our current is always at 0, but the things that we worry, the things that's happening in this for loop is we're doing 0, 1, 0, 2, 0, 3, and so on. So we are essentially creating this 1, 1, 1, 1, 1, 1, sorry, 1, 1, and so on. On the second level of recursion, and there's a second level on each one of these, is going to be Well, 1, 1, 1. But there could also be 1, 1, 0, 1. And this is all in the case of just 4. 0, 1, 0. Let me add a 0 here. Let me actually add 0, 0 just to make it more. The second one is 0, 1, 0, 1, 1, 1, 0, 1, 0. And finally, yeah, this is it. This is the, what am I missing? Oh, what I'm missing here is a third level of recursion on this number. There we go. So if we were to exclude this first number from all the different combinations of these 4 numbers, you would actually see that the that the 3 numbers are still arranged uniquely. Right? We have a 1, 0, 0, so there should be what, 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 2 to the third power. 8 different combinations of these 2. But keep in mind that all of this level of recursion is happening only on our first level. On our first level of doing 1 here, of exploring the possibility of 1. On the next level of recursion, which we are also doing in later scenarios, is 1. No, sorry. This was already included in the instance where we propagated to the sun. Yeah. Okay. Well, anyway, I hope this made sense. Let's quickly look at a couple of different solutions. I maybe think that there should be 1 or 2 that are different. My submission code. That's solution path. Yes, and they're also using the backtracing approach and backtracking, actually. That's what it's called. But yeah, even here they're doing the same exact thing. I don't know why this is faster. So mine was, oh, well, it's only milliseconds faster. Let's see some of the more difficult solutions. Actually, no, I'm not going to do that. Why would I do that? Anyway, thank you for watching. Catch you next time. Bye.